If it is audible, we can go ahead and we will start. It will take some more 10 minutes for me to settle down because I am now in another place. It's not the usual place where I used to take class. Okay, so what we will do with what we have seen in the previous lecture, and then we will go for the subsequent topics. In between, if you are having some questions, you can always ask me because it's in the full screen sharing mode and I cannot see if you are writing something in your chat box. Okay, if somebody is having some doubt, you can always unmute their mic and ask the questions to me. So in the previous lecture, we have discussed about what is an electric circuit and what are the things associated with that. So we are having the batteries, current source, resistors, switches, capacitors, inductor, diodes, transistor, operational amplifiers, and so on. And this is what the simplest circuit we have seen. We are having a battery here, and then we are having a lamp. And if you connect it in such a way that the current will flow and the lamp will glow. So this is what the simplest circuit we have seen in the previous lecture, and that's what the complicated one, right? And generally, this is what you are supposed to handle. And these are the systems of unit. Everyone must have recalled it that these are some basic fundamental units, and rest all are the derived units out of it. And now the concept of charge. So it was discovered by Charles Augustin de Coulomb, and that's why the unit of charge is given as Coulomb, and it is 1.602 into 10 power minus 19. So classification of material, that also we have discussed in the previous lecture, that is conductor, insulator, semiconductor, and based upon band diagram also, I asked you to recall that thing. And that is for the current. So current is rate of change of charge. So that is given by dq by dt. And it was given by ampere, and that is why the unit is again as given as A, that is the ampere. Now, originally the current was considered as because of the movement of positive charges, and that is why the current direction also considered in the same way. But later they found that there is nothing called the positive charges in the conductor. There is something called as the electron, which consists of negative charge, and that flows opposite to that of the current, and hence the current convention has been changed. Okay. So when the electrons are flowing from, let us say, this is left and that's right, from right to left, then obviously your current is flowing from left to right. So that is what is the very fundamental and basic things which we have seen in the previous lecture. I hope you everyone are able to recall that one. And there is something called as a direct current and the alternating current. Of course, whatever the household lines we are having, that is an alternating current. Can anyone quickly tell me the rating of household line? Just quickly, can
220 volts and 50 hertz, sir.
Okay, good. So this is what the rating of household appliances we are having, and what once you come here, what we can have such experiment, simple experiment. I don't know whether you have seen or not. If you just simply take this and put it in the CRO, you will get a pure sinusoidal wave. And in case you are not getting a pure sinusoidal wave, that means some ripples are coming in your household supply line, and that may damage your the household appliances, right? So getting a pure sinusoidal is very important when you are working with the home appliances, right? So that is why some different circuitries or things are used to make it stabilize. Now, the voltage is also called as electromotive force or potential, and it is defined as the energy required to move a unit charge through a circuit element. Right, all these are very fundamental and basic definitions, so I'm not going to elaborate too much. Just to recall all these stuff, I am just telling all these things to you. And of course, it was given by the Voltas, and he was an Italian physicist, and that's what the equation or definition for the voltages. Now, similar to the electric current, this just a moment, please. Okay, so similar to the electric current, as we have seen, the electric current also goes in one direction. You can call it as a 5 amperes. Let us say A to B it is flowing, and you can show the same current which is flowing from B to A, and you can write it as a minus 5 ampere, right? So the current, this sign convention needs to be understood. If your current is flowing from, let us say, A to B, I'll repeat this part, and if it is 5 amperes, okay, then you can always say that the current is flowing from B to A and it is minus 5 amperes. So both means basically same, right? So you can see here the sign convention. If the opposite way you are doing, then you have to put the negative sign. So actually the current direction has not changed, only the representation has changed. In a similar way, for the voltage also you can show that voltage V1 is 2 volt. That means the potential difference between A and B is 2 volts. Okay, so VA minus VB is 2 volts. So what it means, VA is higher than VB by 2 volts. Okay, that is what it means. So it is always a potential difference between two terminals. Similarly, in this case, that is the second case, V2, which is VA minus VB, is minus 5. So what exactly it means, that VA is lower than VB by 5 volts, or in this way if you want to write, then you have to write minus 5. Okay, so that's what it means. So you can write VA minus VB is minus 5, or else VB minus VA is 5 volts. So which one is at higher potential? This VB is at higher potential and VA is at lower potential. That is what it means. And in the same way, you can conclude for even the part C also. And this is what which I have discussed just now can be seen here in these two representations. Let us assume in this case you are having some certain element which we are not interested in knowing what element it is, and we are only interested in knowing the voltage difference between point A and B. So you can call that as a VAB. And what exactly is VAB is VA minus VB. This is what the general convention of writing it. Okay, whenever there is a voltage which is written as, let us say, XY, so it always means VX minus VY. Don't consider VY minus VX. Okay, don't try to have some new set of nomenclature for that. Just take it as it is, and then VA minus VB in this case is 9 volts. And in this case, can anyone comment whether what could be written here, whether these two are same or different, A and B? Can anyone
VB
comment?
minus VA is 9 volts, sir.
So whether those two equivalent circuits are same, VA and the circuit number, let us say A and B, whether they represent the same element or it's different?
Same, sir.
Same, sir.
This magnitude is different.
No difference. Who is saying some difference is there?
Yeah, it is same, sir.
There is no difference, right? It's just the representation.
Yes, sir.
So this is VA minus VB is 9, right? So both are representing the same element. Now there is something called as a power, and power is called as the rate of change of energy per unit time. Okay, so rate of change of energy per unit time is called power, and it is measured in terms of watts. And obviously, why watts? Because it was given by James Watt. Okay, a Scottish inventor and a mechanical engineer. Now, see, mechanical engineer has given for the electronics item, so don't worry about that. It is not discovered in this way. So P is equals to V into I, and we are having different types of component. That is the passive components or passive element, or active components or active elements. We will see later what exactly the passive and active means. Okay, but just at this time, I can tell you that this inductor, capacitor, and resistor are called as the passive. Okay, which do not have their own source, so those are called as the passive elements. So generally, the passive elements absorbs the power, and the active elements delivers the power. That is what is called as the active passive, or the absorb power and the delivered power. Okay. So how we can do that from the sign convention of the circuit? So for calculating the absorb power, what we have to do is, if any circuit is given to us, we have to first find out the power. Okay, so what is power? V into I. That is, for this element, you want to find out whether it is absorbing the power or delivering the power. So what is the first step? First step is to find out power. Okay, so V into I. And now just read this statement. Voltage drop from A to B. So what is the voltage drop from A to B? It is 4. And multiplied by the current through the element from A to B. So current through the element from A to B, it is 3. So 4 into 3, that is 12. Okay. Now, this is a positive value. With this convention, if P is greater than or equal to 0, then the element is absorbing or consuming power. Otherwise, it is absorbing negative power. That means delivering the power. Okay, it is generating the power and giving it out. Similarly, here also you can see. Can anyone tell me where this is absorbing? I hope this is understood to everyone. This is 3 into 4, that is 12 plus 12. Can anyone comment what about this circuit, whether this is absorbing or delivering? What is the power here? Yes.
Absorbing, sir.
Anyone else? Winston has given absorbing. Anyone else?
Absorbing, sir.
Observing, sir.
Fine. Why it is absorbing? Because if you consider even this as A and that's as B, then the voltage AB is minus 4 and A to B, the current which is flowing is minus 3. Okay, so minus 4 into minus 3 obviously leads to plus 12 and hence it is absorbing. Now can you comment quickly for this?
Delivering.
What about this one?
Absorbing.
Delivering.
Delivering.
Bhavana, am I right? Bhavana is giving the answer for that. It is anyone else? Yashwant Kumar, Siddharth, Mahidhar.
Sir, delivering, sir.
Fine. Okay, so this is also delivery. So is that clear how to identify whether the power is delivered or this thing? Right. Now we will go to the next part. So as I told you, I will come to the definition. What exactly is the active and passive? So an active element is capable of generating energy, and passive element is an element that does not generate energy. However, they can consume or store the energy, right? So what are the active elements? Current sources, voltage sources are called as the active element, whereas the passive elements are resistor, capacitor, and inductors. Okay, so these are your passive elements. Generally, when we consider the electric circuit, most of the time we will be dealing with that, and hence the examples are taken for the same, right? So resistor, capacitor, inductors are the passive elements, and the current source, voltage sources are your active elements. Now coming to what is an ideal current or voltage source. So in that also we are having two bifurcation, the independent source and the dependent source. So let us see what exactly the independent source is. An ideal independent source is an active element that provides a specified voltage or current that is independent of the other circuit, how the source is used to the circuit. Now, to understand this, let us recall your basic pencil cell. I hope everyone must have seen in their life this double A battery and double A or triple A. Can anyone quickly tell me what is the rating of AA battery? Please. What is the rating of AA battery or AAA battery? Durga, Ashini, Chandru, Deepa, or else what is 105? 1.5. Okay. Anyone else? Tawfiq, Jubin.
$50 sir.
Devan, Hari, Kalidas, Ajay Kumar, Naveen. Hey, these people are there or not? Or they are just living somewhere? Or doing some other job? No. Just look for what is the voltage. First voltage, then only current. Okay, so it is 1.5 volts. Fine. Now, generally in your clock or some remote, you will be placing it. Okay, a single battery generally in the clock or wall clock you will find it. Remote sometimes two batteries they are using. So let us consider the simplest example clock. Now, irrespective of the circuit, it has to always maintain a voltage of or a voltage difference between its two terminal plus and minus as 1.5 volt. Okay, irrespective of the circuit. That's very important. So it is a constant voltage is seen at the output terminals of battery irrespective of the circuit. Okay, it's not like if you are adding some circuit to your cell or a battery, it will change this voltage. That is not going to happen, right? So what exactly it means? This is the definition. Okay, if you now read this definition, it's an active element that provides a specified voltage. Okay, specified voltage. Please understand this. The specified voltage means 1.5 volts for your battery that is independent of the other circuit elements or how the source is used in the circuit. Is that okay now? So it doesn't matter if you are taking the battery, let us say this small experiments you can do. It's not even experiment, also some hobby. You can take this battery and if you connect, let us say, some resistor here or maybe a lamp or something, or a very small one. So it doesn't matter if, let us say, this load comes around as 10 ohm, still this difference from these terminals 1.5, even if you make it as 100 ohms, still it will be 1.5 volts. Okay, so that is what is called as the ideal independent voltage source. And in the similar case, the current source also, that we will see in the next slide. And the symbol used for the independent voltage source is here. Generally, we will show in this way. And in case of time varying, you will be showing one time varying symbol. And in that, if it is a DC is imposed on it, then you will show like this. Okay, is that fine? So this is how it goes for the ideal voltage source. And then coming to the current, the equivalent representation of the ideal current source whose current IT is maintained under all the voltage requirements of the attached circuit, right? So whatever circuit you connect here, the ideal independent current source value will not change. Okay, so please keep in mind when you are saying independent, just go for its word meaning. Independent means it is giving by its own, it's not dependent on anyone else, and hence its value will not change. If its value is changed, that means there is a problem in your source. How to recall it? Let us say if the battery is connected to the wall clock and the clock is not working, or it is showing, let us say, 10 o'clock when there is 1 o'clock. Right? So what is happening? It's going slow. Okay, that means obviously the battery is not able to provide the 1.5 volts. Because of that, the current is not coming properly and the circuit is not operating in a correct way. What exactly it means? It means that now the battery needs to be replaced. Okay, why you are replacing the battery? Because now it is not acting as a ideal voltage source. Is that clear? Why you are replacing the battery? This is what very fundamental, and this you can see from your day-to-day life. Right? You are doing all this stuff, but you are not looking from that point of view. That's the only difference. And how you will label the current and voltages? This is how the voltage currents needs to be labeled. Please understand, if unknown circuitry is there to you and you are connecting a voltage source to it, then you have to always consider the voltages, so the current is moving outwards in this way. Similarly, if you are having a voltage, if you are having a circuit here and you are connecting a current source with upward direction arrows, then you will always count the voltage drop in this way. Okay, so this is what the standard current and the voltage labeling. Is it clear? Is there any doubt so far? Shall we go ahead?
Yes, sir.
Okay. Now coming to the one example, what is the power absorbed or supplied by the elements for the following network? Now this you have to tell me what is the power absorbed or delivered for these 1 and 2 elements. Quickly please tell me. Yes, please.
Sir, first element 12, sir.
Plus 12 and
36.
so both are positive means what? It is delivering or absorbing.
Absorbing.
That means some passive element must be connected in this place. Okay. Now, one can see here 2 important aspects, out of which one I will just tell you what is that. If you do algebraic sum of voltages, okay, it can be the source voltage or it can be the drop also, you will find it leads to 0. How? Let us take, I am taking this, let us consider I am taking this as a direction. I have started walking from here, okay, in the circuit. And I am taking those signs which I am encountering first. So in this case, I have encountered minus 24. Now I started again, I went up to this element and I found this positive. And this voltage is mentioned here. So plus 6. Then again I started from this point. I moved further and I encountered this positive sign again. And what is that? It is, the value is 18 volts. Then I moved further. I did not find anything, any other element which is either delivering or absorbing power or any element. Neither any source also, right? So I have reached again to the starting point. Now I will stop here. Let us do the algebraic sum. And this leads to 0. And what is this? What is this called as?
Kirchhoff's voltage law.
Kirchhoff's voltage law. So what Kirchhoff's voltage law suggests is the algebraic sum of voltage in a closed loop is always 0. Okay, it's very important fundamental law. Algebraic sum of voltages in a closed loop is always 0. Okay, that means in notation wise you can write in this way. Now please understand what is the meaning of algebraic. Algebraic means you are taking care of sign convention. Okay, that means this negative and positive. Please remember, whenever you are doing such an analysis, either you take the entering sign or you take the leaving sign. Okay, let us say if I take leaving sign, then plus 24 will come. Next, here it is minus, so minus 6 will come. And then you are having negative, so negative 18 will come. So this also leads to 0. So generally we will take the sign at entering point. Okay, this is the best way to recall and understand this. You are walking inside the circuit and whatever the sign comes inside at the entering point, that only you have to take care. Okay, then the rest of the things you will automatically manage. And now what is the ideal dependent controlled sources? So we have seen independent and now it is the dependent source. So ideal dependent sources in an active element whose quantity is controlled by the voltage or current source, voltage or current of any other element, right? And these are represented by this diamond shape. As I told you in the first lecture also, the dependent sources are always represented by this diamond shape. And its values are dependent on some of the element of your circuit. Okay. So these are all we'll see in our subsequent classes. Now this is the general structure. We are having 4 different types of sources. Now please understand, we are having current and voltage and dependent independent combination. So you can have 4 combinations out of it, that the current is dependent on voltage, voltage is dependent on current, and the vice versa, which is shown here. So let us see what exactly all these 4 combinations are. So this is the 2-port network. This is called the 2-port network. Why 2-port? Because we are having one input port, and this is called as the output port. Okay. So what is this? This is called as a voltage controlled voltage source. Why we are calling it as a voltage controlled voltage source? Because the output voltage is controlled by input voltage. Okay, how you are saying that this is a dependent source. Okay, this is a dependent source, and the value of this, that means the voltage of this dependent source, that is Vt, Vs of t, is dependent on the voltage of this input port. Okay, or this side of the circuit. Look at here, this, what is the value of this voltage source? Value of this voltage source is alpha times, where alpha is some constant, alpha times Vt. So whatever changes in Vt, this, some combination of that will be reflected in the dependent source. Is that clear? And hence we are calling this as the output voltage is controlled by the input voltage. Now let us come to the voltage controlled current source. So this is the current source, and its value is dependent on the voltage of this element, and hence we are calling it as a voltage controlled current source. Is that okay? This voltage, the voltage across this element is controlling this current source. Okay, you can consider it this way. Voltage is controlling the current source. Is that okay? Similarly, the current controls the voltage source. If the current is controlling the voltage source, then you can call it as CCVS. So which current is controlling? This IT is controlling which voltage source? This voltage source. So this is the voltage source. How you are identifying? Because the plus minus signs are given. I told you if plus minus sign are given, that means it's a voltage source. If the arrow is mentioned, then it is the current source. So here plus minus signs are mentioned, that means this is a voltage source. So voltage source is dependent on current of this element. And what is that? IT. And hence we are writing VST, that means the voltage source is dependent on the current of this element. Similarly, there is something called as the current controlled current source. So current of this source is controlled by the current flowing in this element. And that's why you are calling as a current controlled current source. Is that okay? Is there any doubt now? Are you able to understand there are four combinations which are possible? The voltage controlled voltage source, voltage controlled current source, current controlled voltage source, and current controlled current source. Is it clear?
Yes, sir.
Sir,
Yes.
current source is, when something is current source, it will have a voltage also. Sir. Like if it is producing current, it will be producing the current because of a voltage. So like, what is the difference? Both are same or what? Voltage source and
No, I will give answer in the other way. Okay. What is the current flowing in the battery? Because both are a complement of each other, so I will give answer for your battery, and then you have to think for what is happening with the current source. This is a voltage source. Am I right?
yes, sir.
What is the current flowing in this?
That depends on the.
Absolutely right. That's what your answer is.
Oh, okay.
Now, the next question comes. Somebody has written some ampere value when I have asked for the voltage. I will tell you who has written. I don't know. Sanjay Reddy has written at 10:20 or 10:19 in the chat box. I do not know whether he has seen it somewhere or else.
Well, sir, there's batteries like that which produce particular current, but then their voltage will be dependent.
No, no, we will not call them a battery then, we will call them a current source. Okay, battery generally used for the voltage source only. Now, my question is, there must be some current rating also.
I've never seen that, sir.
Okay, okay, then come to the household appliances. That is the best example.
Okay, sir.
Okay, you must have
They'll
seen.
have power rating.
Absolutely right. I'm coming to that point only. You have in your room, in your house, generally two different types of what is called as a pin. A one which is smaller, where you will generally connect your charger. Nowadays, most of them are having this third point also. So let us consider third is also there. And then a bigger one, where you will connect your what is called as AC or refrigerator or maybe your water pump. You will not connect the air conditioner to the one in which you are connecting the charger. Anyone has observed? Is there where you are sitting? Can you observe this thing?
Yes, sir.
What is the reason?
Sir?
What is the reason why two different things are there in your house?
I don't know what is this.
Grounded, sir. Is connected to ground.
Whether my question is clear? I hope. See, let's come to our actual question and answer. You have asked why we are not saying the voltage across the current source. So for
Sir,
that, I have
that AC one is current source, sir. Like that is the difference between those two.
can you elaborate? I'm not able to understand what you are saying.
The difference between those two types of pins is that the ones which need voltage source will be connected to one particular pin. The ones which need current source will be connected to other kind of pin. Is that the difference?
Okay.
No, sir.
But what about the voltage?
Don't know, sir.
Oh, what is the household supply?
220, sir.
220.
Yes, sir.
So what do you feel? What must be the voltage across that smaller one where you are connecting charger and the other one, the bigger one where you are connecting the AC? Anyone?
One will be grounded, sir.
Or in nahi baba. Third, you leave that third part. Okay, that is obviously there. Nowadays, this two pin idea is generally not there. Okay, all are three pins only. So that ground portion you leave. What I am asking is, I am saying about the voltage. One by one we will go. But quickly, we will wind up this quickly. Somebody is able to access their AC right now. Whether stabilizer is there in your AC, the additional box.
Yes, sir, that's the voltage stabilizer only.
What is the rating written there?
The rating, sir, I don't remember the rating.
You can stand and you can see that one.
I don't have an AC in my house, sir.
Okay, those who are having, at least one may be having, right? And that too nowadays you see the Burj Khalifa, you will not get either. You have everything in your internet. No, it's not 440 volts. Don't give wrong answers. And I don't know for what reason you are putting smiley. Please don't put smiley. Okay. Don't go to the phase. It's a different idea. It's not 440 volts. out of this 60 candidates, nobody is having any way to find it out. Into pin voltage, they will be ground 5 to 10 volts. No, it's not like that. See that this is what the biggest difficulty. From your childhood, you are seeing that switches, but nobody knows the rating of that one. So what I leave this question half answered and half unanswered. You have to find out the voltage rating, current rating, as well as the power rating for that. Okay. I will tell you one simple way to understand it, but you have to find it out, and tomorrow's class I will be asking it. One is called as the 5 ampere switch, and the other one is 15 amps. Why 15 amps? Even though the voltage is same, okay, even though the voltage is same, the load is high, okay, and it has to withstand with the high current. Because of that, the power dissipation will be high. Okay. So, in order to withstand with the high current or the higher power dissipation, you need to connect to the 15 amps switches. If you simply connect your AC with the 5 amp switch, definitely it will trip. Okay, the main switch will get tripped. And now that's a different part, that how the tripper is working. But this is what the general idea. Now coming to the initial question, why we are not commenting the current of your battery. Okay. So it depends on the amount of load if you are connecting it there. Now if I take a 1.4 volts battery and if I connect a resistor of, let us say, 10 ohms, what is the current? Current is 1.5 divided by 10, that is 0.15. Similarly, if I connect to, let us say, a 3 ohms load to your battery, which is again 1.5. So 1.5 divided by 3, what is that? 0.5 amperes. Okay. So the voltage is same, the load is changing based upon your requirement, and the current is also changing. And that is why it's not giving a constant current to you, rather it is giving a constant voltage to you. So now what is the current rating for that particular battery? Current rating which is available to your battery gives the maximum or sometimes the minimum current. Generally minimum they won't write, maximum only makes sense. So the maximum current which can be drawn out of this, okay, in that it will work. You cannot expect that you will connect something like 1 giga ohms to it and then you will see some value out of it, right? So it's a negligible current to it. So that is how the current ratings and the voltage ratings are defined for such kind of things, similarly to your household. Now, you have asked for why the voltage is not mentioned for the current source. The same reason applies why the voltage is not mentioned for your current source. It will only speak about how much current you can draw, how much a constant current you can draw out of it. The voltage again depends on what kind of load you are connecting. Okay, if it is a 10 ohms, then if the current is 5, then it is 50 volts. If it is 100 ohms, and if the current is 5, then it is 500 volts. That is why the voltage is not written for that way. There is one more reason which I will come to in the subsequent lecture. Is that okay? Shall we move ahead? Last part and then wind up. But what you have to do is you have to find out what is the current rating of your household appliances. Whatever household appliances is there in your home which you are using from long, you have to find out the voltage rating or the current or the power rating of that. And for your mobile, for your charger, for your laptop charger, for everything, whatever electronic appliances you are having, you should know the current and voltage rating of that. So mobile works with the AC or DC? Very simple question. Mobile is working AC or DC?
DC, sir. The charger converts it into DC and then it charges the
Correct. So
mobile.
you're storing in a big capacitors sort of batteries, and then it is basically providing the DC anyway. But that's what I'm saying, that everyone should open their mobile phone, see what is the rating for their batteries. Sometimes nowadays it is available at the about us or something about option in your settings. But these are all are general awareness, right? Nobody is going to ask this in your examination. But if you don't know this, then there is no worth in having such a degree which will not speak for you, right? So this is very important. You should have seen, we are using it for such a long while, but we do not know what is the rating of the household. And the biggest insulting thing is a 10th standard mechanic will come, the electrician will come, and he will sort out your difficulties for the home appliances. So even if you are not able to sort it out, at least you should be able to figure it out. Okay? Is that okay? Is that convincing? Does that make sense to you? Even if
Yes,
you are
sir.
not, isn't it? If you are not able to sort out the difficulty, at least you should be able to figure out the difficulty. If you are able to figure out the difficulty, 50% problem is solved. Am I right? If you are able to figure out the difficulty, your 50% problem is solved because you have defined the problem. Fixing it is a different part, but at least 50% you should try. And that is for everything, not even for the home appliances, for the entire thing, for your courses, for your studies, for everything. Now coming back to the last point, that is for the resistance. It is a constant for proportionality, that is the resistivity of the material, which is given by R. So this proportionality constant is given by rho, and it is L by A, where L is the length. And that's the cross-section area. What is cross-section area? This is your cross-section area. And what is length? This is your length. Okay. And the resistivity is the materialistic property. That means what? If you change the length or A is a materialistic property. Okay. But the resistance will change. Please understand, if you change the length or area, the resistivity will not change, but the resistance will change because it is proportional to that. Why this is not changing rho? It is a materialistic property. It depends on the material. Now, who has identified this? George Simon Ohm has identified this. He was a German physicist, and that's why the unit is given by Ohm. Okay. So in a daily practice, see how much we are taking the name as if they are God, and of course they are God because they are given all this beautiful stuff. Now, in the next lecture, we will go for what is the Ohm's law, what are the basic types of circuits and all, series, parallel, and then we will solve for some of the basic fundamental circuits, starting from the KCL KVL implementation. Okay. Is there a doubt in today's lecture? Is it good? Any comments you would like to mention for today's lecture? Because in this phase only we are going to move for the subsequent. Is it fine? Are you able to relate and understand the concepts of the things? Please quick feedback.
Yes, sir. Yes, sir.
Okay, so what is the stuff now you have to do? Okay, just don't open all the appliances of a home. Be careful and check out the ratings. To check the ratings, you need not to put your hands inside the switchboard. Please understand. Google is there, it will help you. Or if somebody is having some boxes of your switches, they can check in that. Okay, don't do some work like, okay, our faculty has told to check it, so let us check it out. It's not the way to find it out. There are simpler ways to do it. Okay, but at least for mobile phone chargers and these things, you have to check and you have to tell me in the next section. Okay, that's it for today. Thank you, everyone.
Thank you, sir.